Welcome back. If you're joining us again, you know we're on this awesome journey to understand how governed AI architecture actually operates in the real world. In our first explainer, we covered the why. Why durable, governed continuity is literally a must-have for AI. Today, we are taking the next massive step. We're answering the big question. What does a system architecture look like when no individual agent, no single runner, and no execution session is allowed to become the system of record? Welcome to part 2 of our deep dive. Let's get right into the GhostMesh architecture.
Okay, let's dive right into our roadmap for today. We'll start by moving beyond ephemeral AI agents. Then, we'll unpack durable state and work identity, look at how we coordinate temporary execution workers, dive into governance, evidence, and memory, assemble the entire governed execution fabric, and wrap up with the next big architectural challenge.
Part 1. Beyond ephemeral AI agents. Separating capability from authority.
To really grasp GhostMesh, we first have to look at the extreme fragility of most modern AI setups. Think about it. When your entire workflow relies on a chat session or an agent, that temporary worker is holding literally all the critical context. If that session drops or times out, bam, the context just vanishes. GhostMesh introduces a massive paradigm shift here. The core argument is that an individual agent or session should never be the permanent system of record. Actually, scratch that. It can't be. The system of record has to be a distributed, durable state that lives completely outside of the worker.
And that brings us to the core motif of this whole architecture. The ghost represents temporary intelligence. Think of an ephemeral worker, a reasoning session, or a cloud runner that spins up, does its job, and just disappears. The mesh, on the other hand, is the persistent system. It holds the durable authority, the state, and the evidence. This decoupling is honestly where the magic happens. It allows the ghost to completely vanish because the mesh retains everything that actually matters.
GhostMesh is a persistent system built from temporary intelligence. If you take away absolutely nothing else from this explainer, let it be this exact concept. GhostMesh is not primarily an agent architecture. It's an execution and continuity architecture. The intelligence is totally temporary, but the capability, that remains. Part 2. Durable state and work identity, making unfinished work addressable. So, if the worker is temporary, how on earth does the system maintain state? Like, how do we even make unfinished work addressable? Well, the answer lies in source-supported identity mechanisms, which are heavily backed by Git. We're talking about using repositories to provide persistent artifacts and recoverable checkpoints that don't depend on the active worker at all. Let's break this down. GitHub issues become your durable record of intent and authority. Pull requests are your proposed changes. Git branches act as bounded workspaces. Immutable commits, they serve as your exact state authority. And executable receipts act as observable evidence. The repository isn't just a place to store code anymore. It is the durable, long-term memory of the entire system.
So the crucial point here is that exact commit identities are absolutely mandatory in a distributed setup. Because think about what happens when you have multiple agents working super fast across all these different tasks. Vague phrases like the latest version or the current branch become hopelessly unreliable. By tying execution to an exact immutable Git commit, the system guarantees that work is happening on a verified state. It completely eliminates the chaos of overlapping or untracked changes.
Part 3. Coordinating temporary execution workers. Replaceable capacity and explicit coordination.
All right, now that we have a durable state, let's talk about the workers themselves. In GhostMesh, AI agents are not treated as these omniscient, all-knowing beings. They are literally just one of many types of replaceable execution capacity. You've got Cloudflare workers handling the event and runtime fabric. You've got GitHub Actions CI runners dealing with deterministic execution. Then there are sovereign local systems running on owner-controlled compute. And of course, things like the Codex CLI or AI agents stepping in for model-backed reasoning. They are all just different forms of replaceable capacity plugging right into the mesh.
But how do these totally different workers avoid just constantly overwriting each other's work? They follow a very precise distributed coordination loop. First, unfinished work is made addressable, meaning it's clearly identified in that durable state. Second, before a worker does anything, a claim and lease are explicitly acquired. This establishes explicit coordination. Third, the actual execution happens, where the temporary worker performs a bounded mutation. And finally, an observable receipt is emitted. This generates undeniable evidence of what happened before that worker disappears back into the ether. This exact choreography is what stops the mesh from turning into a chaotic free-for-all.
Which brings us to a fundamental rule of this architecture. There is a massive night-and-day difference between an agent says it completed the work and the system contains evidence proving what happened.
GhostMesh demands verifiable receipts and exact state transitions. A chatbot giving you a confident "done" is not execution evidence. The system demands mechanical proof.
And this brilliantly illustrates the whole concept of execution economics. The system actually routes work to the least expensive, most deterministic class available. You have human authority for consequential judgment where high attention is needed. You have direct connectors for exact supported operations at a minimum trusted cost. Then you've got deterministic adapters doing the building, testing, packaging, and deploying on cheap, repeatable infrastructure. You only ever use the model-backed delta, with its high token and reasoning costs, for the absolute smallest unresolved piece of novel logic. You're not going to use an incredibly advanced AI model just to move a file if a cheap deterministic script can knock it out perfectly.
Part 4. Governance, Evidence, and Memory. Observing the system without becoming it.
To govern this massive system without accidentally turning into a bottleneck, GhostMesh uses totally distinct control and memory planes. First up is the control tower. Think of this as the central governance surface. Its job is to observe work across the broad repository estate, verify deployments, monitor execution state, and ensure exact handoffs are ready for the human owner. Crucially, it observes the mesh, but it does not act as the entire mesh itself. It's the lens, right? Not the engine.
Then we have the memory component, which the source material calls Tony Brain. This provides contextual retrieval, and we really have to define this carefully. It is distinctly separated from state, execution authority, and evidence. It is a measured retrieval tool for knowledge context. It's not some omniscient, magical AI that runs the show.
And you can really see the engineering discipline on display when you look at the stats. Instead of just dumping hundreds of thousands of messages into a vector database and hoping for the best, they bounded their uncertainty before trying to scale. They started with a strictly bounded corpus, just 50 out of over 5,600 conversations. Only 1,690 of over 190,000 messages were indexed. They proved lexical full-text search first and intentionally left semantic retrieval inactive. It was all about focusing on qualifying segmentation first. It's a really disciplined approach. Bound your uncertainty before you scale the memory.
Part 5. The Governed Execution Fabric, Assembling the Complete Architecture.
All right, we have reached the climax of our teardown. Let's bring all these decoupled planes together. Now, what's really interesting here is how these distinct pieces combine to totally tame the chaotic nature of AI. You start with durable, Git-backed state. You add distinct work identity managed by explicit claims and leases. You dispatch ephemeral, replaceable workers who then emit verifiable receipts. The control tower sits above, governing it all, and hooking into the deployment infrastructure while strictly bounded knowledge provides the context. Add it all up, and you have a governed execution fabric where AI can safely run without ever taking over the system of record.
But, no architecture is truly proven until it hits a wall. Let me tell you about the August 6th GitHub provider outage. On that morning, a major Actions and Pages outage kicked off, totally throttling webhooks. But at the absolute peak of the outage, GhostMesh didn't fail silently. It actually preserved a queued state, proving the safety plane worked. By that evening, though, the outage exposed an uncomfortable truth, an over-reliance on GitHub Actions for control. So from August 7th onward, they initiated sovereign local execution as the next resilience boundary, using owner-controlled compute to get true provider independence.
So, why does all this actually matter? Because a workflow that runs successfully on a sunny day is really just a demo. The mesh became real when the provider degraded, the intelligence could leave, and the system seamlessly continued. That is governed continuity in action.
Part 6. The next architectural challenge. The reality of durable pickup.
We've seen exactly how GhostMesh separates work from workers. But as we look ahead, there's a huge operability gap still hanging over us. If one worker vanishes and the state is perfectly preserved, how does the next worker safely, accurately, and economically continue that exact piece of work without losing a beat? That is the reality of durable pickup, and it's the exact distributed systems puzzle we are going to crack in Episode 3. I seriously hope you're as fascinated by this as I am. See you in the next explainer.